And we're back to conclude section 5.5, our solving of non-homogeneous differential equations with the constant coefficient method. Let's look at example 4. Let's find the general solution for y triple prime plus y double prime equals 3e to the x plus 4x squared. Once again, we notice we have a linear differential equation with constant coefficients, and it's non-homogeneous. So we will take a look at the homogeneous solution first. And so we're going to get a characteristic equation of r cubed plus r squared equals 0, which we can factor as r squared times r plus 1, which tells me that my solutions are equals 0. So r equals 0, 0, and -1. So that would mean that the complementary solution is c1 e to the 0 x plus c2 x e to the 0 x plus c3 e to the -x. Or in other words, y sub c is equal to c1 plus c2x plus c3 e to the -x. However, if we look at the non-homogeneous part, we notice duplication of, so we have 4 x squared. If we were to put that in as our particular solution, so y sub p equals ax squared, and we also look at his derivatives, plus bx plus c, we notice that we have some major duplication with the homogeneous solution, the complementary solution. So what we need to do is adjust our particular solution so that he and his derivatives don't have any duplication with the complementary solution. So the way we're going to do that is we're going to take our particular solution, trial, and if we multiply by an x, we'd have ax cubed plus bx squared, which is good because there's no x cubed or x squareds here, but the cx would duplicate here. So multiplying by x is not enough. We need to multiply by x squared so that we have ax to the 4th plus bx cubed plus cx squared, which has no duplication with the complementary solution. And so let's take a look at him. Oh, and by the way, we also need in there, so here's this guy. He was a duplication part, but we also need to take into account d e to the x. So if we take y sub p prime, we're going to get 4ax cubed plus 3bx squared plus 2cx plus d e to the x. Yp double prime will be 12ax squared plus 6bx plus 2c plus d e to the x. And remember that this was a third order, so we're going to need a y triple prime equals 24ax plus 6b plus, that's going to go to 0, d e to the x. So I'm going to need just a little bit more space, so we'll continue down here. Let me slide that up for you. So let's take a look at yp triple prime plus yp double prime, and that should be equal to 3e to the x plus 4x squared. Plugging in to pick up our non-homogeneous piece, we've got 24ax plus 6b plus de to the x. That all is the yp triple prime, plus yp double prime is 12ax squared plus 6bx plus 2c plus d e to the x. And if we take a look at that guy and then set him equal to the non-homogeneous piece of 3e to the x plus 4x squared, let's see what happens. So we notice that we've got 12ax squared. Okay, let's see if we've got, so we've got some x's, so we've got plus x times 24a plus 6b. Looking at constants, plus 6b plus 2c, and we've got 2d to the x, and that should equal 3e to the x plus 4x squared. Okay. Again, since we've got our equation here, let's equate like coefficients. So the x squared coefficient should be the x squared coefficient here. So we should find out that 12a equals 4. So in other words, if a is 1/3, that would make that true. Looking at the linear coefficient, notice that this would be plus 0x, so the coefficient should be a 0. We will find out that 24a plus 6b is equal to 0. Knowing that a is 1/3, this would give me 8 plus 6b equals 0. So subtracting 8 and then dividing by 6, b would equal to -8/6, or in other words, -4/3. And looking at the constant term, so the constant term would be plus 0. So we've got 6b plus 2c equals 0. Knowing that b is -4/3, so we'd have 6 times -4/3 plus 2c equals 0. So 3 will go into 6 twice, giving me a -8 plus 2c. So 2c equals a +8, so c should be equal to a 4. And then finally, we can look at the coefficients of e to the x. So 2d needs to equal 3. Therefore, d should be equal to 3/2. And so our particular solution, he's big. So a is 1/3. So we'll have, if we go back up here, 1/3 x to the 4th plus b, whoops, that's going to be a minus 4/3 x cubed plus c, which is 4x squared, plus d, which is plus 3/2 e to the x, plus, so that's our particular solution. Then if we want to make the general solution, we do our homogeneous piece plus our particular solution, plus our particular solution. And so that would be C1 plus C2x plus C3 e to the -x. Ooh, and that tells me I need to do one more thing. Plus 1/3 x to the 4th minus 4/3 x cubed plus 4/1 x squared plus 3/2 e to the x. And if we had our initial conditions here, oh, and I need one more initial condition, so let me throw in there that y double prime of 0 should equal, I don't know, I could make something up like 3, my favorite number. Now, knowing 3 initial conditions and given this equation with 3 unknown constants, C1, C2, and C3, we can then solve that using these initial conditions and find the particular C1, C2, and C3 that will work. I hope that has made sense, and we'll see you in the next video when we learn about the other method for solving non-homogeneous linear differential equations.